Hello everyone. Solar panels or solar cells are one of the best things that can be used in electronics projects, either big or small, because they can be used to generate power or can be used to sense the intensity of something. And in this video, I want to talk about solar panels, their history and their types, and also using it with any MCU board or any microcontroller. And I will also talk about how to measure its voltage and how to plot its intensity against time and a lot of things. So the video is divided into chapters so you can directly jump into the point you want to see.
A solar cell or photovoltaic cell is an electrical device that converts the energy of light directly into electricity by the photovoltaic effect, which is a physical and chemical phenomenon. It's a form of
In 1839, a French scientist called Alexander Edmond Becquerel observed the photovoltaic effect, which is of course the basis of solar cells nowadays. And of course the developing of solar cells took a lot of time since 1839 till now, till today actually, to see solar cells as we see it today. I will not talk more about the history of solar cells because it will be a history session, not a YouTube video. But I will talk about the types of solar cells and solar panels. So this is the polycrystalline type, which is the most known type, and this is the thin film type. You would find it in calculators and old things. And this is also the polycrystalline type, but in a smaller package. And lastly, this is the monocrystalline type of solar panels, which is the higher in the efficiency and a little bit also expensive. In my opinion, I prefer buying solar panels with aluminum frames rather than buying just solar cells like this, because they can be very fragile and can be broke easily. Also, solar panels can be easily mounted as they have holes to attach to a wall or something like that. Solar panels also have a black box where you can mount and attach all the wires and everything inside that black box, so it looks more professional and better in the design. In normal conditions, you would attach the wire to the bolts like this with this connector, but because the black box is very small and the solar panel itself is very small, I would just connect the DC male wire directly into the bolts and just screw it in place. I have a small converter that converts the DC male wire into a terminal block, so I can screw any wires or anything to measure the voltage, for example. Now I will go outside in the morning, it's around 9 o'clock, and I'll be measuring and doing some stuff and some measurements. Now I will get the connector and connect it to the solar panel, and also I will get my digital multimeter and I'll put it in the voltage reading mode, and I will just put the probes of the digital multimeter into the terminals directly and just screw it. So it's a nice solution. Now I would like to talk about the meaning of specifications of solar panels or solar cells. The maximum power, which is measured in watts, is the maximum power you can just absorb from the solar panel, and you will not reach this point except if you are in direct sunlight and in a special angle that will allow you to absorb this. The same applies to maximum power current and maximum power voltage. These are the maximum ratings the solar cell can just provide while still having amount of voltage to do some stuff. Open circuit voltage is the voltage of the solar panel as soon as it's exposed to direct sunlight, no load connected to it. And the short circuit current is the maximum current the solar cell would have to provide it before the voltage just drops nearly to zero. In order to get enough power from the solar panel, you should never cover any cell or any part of the solar cell or solar panel, because this will affect the voltage. Also, the angle affects the voltage because it's now, for example, at an angle of 45 degrees and have an output voltage of 1054, and now stand still, it have an output voltage of around 1046. I will now put my multimeter in current measuring mode to measure the maximum current the solar cell can provide. You can see that now the output current is around 390 milliamps, but actually the voltage is very near to zero. But as you can see, as soon as I just tilt the solar panel, the current jumps significantly to 450. But also as soon as I cover only one cell of the 18 cells in this solar panel, the current drops from around 400 milliamps into 100 only. So you should probably put the solar cell or solar panel in a place where there is no shadows or anything in the between. I will now make a short circuit to show that the voltage is actually around zero when the current is something like 390 milliamps. And this is a power resistor I will use to show you that also when I connect a big load like this, so it's typically 10 ohms, you can see that the voltage drops to 2 volts. So it cannot keep with this high current drawing it. So you probably have to just charge a battery with the solar cell, not just connecting directly. So this is a wrong thing to do, but I just do it for fun. I just connected an LED, a high power LED, directly into the solar cell. And you can see that's actually just outputting 3.5 volts. As I said, it's more convenient to use the solar cell in charging a battery, not just using the solar cell directly as a power supply. And for this, you probably have to choose a lead acid battery because it's the easiest in charging and it's most tolerant, but it's of course a little bit heavy. One problem when charging batteries using solar cells is a problem called reverse charge. Actually, solar cells work as an LED when there is no light or they are not outputting voltage. So this multimeter is in current measurement mode and it should output a positive current when the solar cell is putting current into the battery. But now it's actually pulling out current from the battery, around 2.2 milliamps. To fix such issue, you would put what's called a blocking diode to prevent the current in the reverse direction. So it's always just getting from the solar cell, not just the solar cell is pulling current from the battery. And this is probably the circuit you would use. I will not talk about the types of diodes you could use and the best one, because like that the video will be too long and too boring, but I will just in short say that it actually works. So now there is no negative current, there is no current being drawn from the battery, only just forwarded directly into the battery from the solar cell. This is a voltage regulator which can be used to lower the voltage of the solar panel like the 9 volts or 12 volts into, for example, a 5 volt compatible with an Arduino, for example. And this is what's called the buck converter, a more advanced thing which actually again steps down but have a higher efficiency. So the efficiency of a buck converter, for example, is between 80% to 90%, which makes it very useful in, for example, battery power projects or solar cells, while voltage regulator on the other hand is very bad. So a voltage regulator efficiency would range between 15% to 50%, really based upon your application and how you use it, but that means that the rest of the power is emitted as heat, which is very bad and very awful, and should not be used with solar panels, for example, or battery powered projects. Another point I would like to talk about is that when you have, for example, a 12 volt input voltage to a buck converter which can supply up to 1 amp of current, on the output of the buck converter you will be able to draw out 2 amps at 6 volts, for example. So always the input watt is always the output watts, while in the voltage regulator, because it's a very old thing and very inefficient, you would actually get just 6 volts at 1 amp and the rest will just go and be wasted as heat. This is a simple circuit I made to charge up the battery I have. It's based upon a linear voltage regulator. I will open my multimeter in temperature measurement mode and will show you the rapid increase in the heat emitted by this voltage regulator, reaching 100 degrees Celsius. I would like to end the video at this point so it's not too long and too boring, but I would like to inform you that soon I will be posting videos about voltage regulators, diodes and everything. So stay tuned and subscribe to the channel. You might go and see the blog I have, and thanks for watching and have a nice day.